this beat is so bitch.
In the last video, we derived an equation of motion for x of t. Remember that x of t is the position of the electron with respect to its nucleus as it oscillates around it. Just the position x of t isn't that useful though. What we really want is the dipole moment. Remember from intro E&M that when two charges have equal but opposite charge, when you separate them by a distance d, they create a dipole moment given by the magnitude of the charge times the displacement. For a hydrogen atom, the dipole moment mu of t is given by negative e times x of t, where negative e is the charge of the electron. Why is it negative though? I thought we were supposed to use the magnitude of the charge. This is because x of t is defined as going from the positive nucleus to the negative electron. The dipole moment though is defined as going from the negative charge to the positive charge. So we add a negative sign to flip the direction. Since we have our equation of motion that we found from last video, we can use the relation we just found between mu of t and x of t to convert this into an equation of motion for mu of t. Just like before, we look at what happens when there's no applied field. When e equals 0, we have an exponential solution that looks like this. Remember that the omega a here is actually the omega a prime from the last video. The values are so close though that we just ignored the difference. This mu naught in front is a constant that depends on the initial conditions of the problem, and it's also complex. Remember that we can write any complex number as a complex exponential. So we do the same thing for mu naught. Using the complex exponential form for mu naught, this is where our solution looks like. This phi here is what we call the phase of the oscillation. When you only have one oscillator, it doesn't matter that much. But when you have more than one oscillator, interesting things start happening. In this video, we derived an expression for mu of t, which is the dipole moment of a Lorentz atom. So far, we've only looked at one atom at a time. In the next video, we'll look at multiple atoms oscillating together and introduce the concept of dephasing.